Hello, everyone. Thank you so much for coming. Let's start. Considering the questions you asked me the last session, I composed the following new section, dark matter non-acceptance. Why? The basic feeling of many physicists is that dark matter doesn't exist because they believe that the dark matter construct was erroneously created due to a false analysis of the expected rotational velocity of stars in the outer range of spiral galaxies, and also presumably due to lack of knowledge about other evidence for dark matter. It is worth noting that in frames of World-Universe Model, there is no need in dark matter to explain galaxy rotation curves. Nick Percival, who knows the opinion of members of CNPS about dark matter, suggested me to put this sentence at the beginning of my second session. I've done it. I absolutely agree with him, and I'm grateful to him very much for this suggestion. The main results of the second presentation, multi-component dark matter, are critical energy density of the world, which provides its flatness, can be found by the Hubble's law only. There is no need in general relativity. Medium consists of stable elementary particles, protons, electrons, photons, neutrinos, and dark matter particles. The relative energy density of ordinary particles, about 4.8% in the medium, which was experimentally measured by fast radio bursts, 2.4% in macro objects, and the rest, 92.8%, is the relative energy density of dark matter particles. What else it could be? In whom there is no dark energy, which is an unknown form of energy that affects the universe on the largest scales. Its primary effect is to drive an erroneously created accelerating expansion of the universe, contributing 68% of the total energy. The nature of dark energy is more hypothetical than that of a dark matter, and many things about it remain in the realm of speculation. In my previous presentation, Angular Momentum, De Hilster wrote the following comment. The word dark is a canary in the coal mine that screams something fundamentally wrong with modern cosmology. It doesn't exist. It is artifact of failed theory. At the same time, Nick Percival said that dark matter womb is really empirically driven model rather than someone doing mathematical manipulation. The host of the session, Ian Cohen, asked the perfect question that demonstrated his deep understanding of the multi-component dark matter. Do you conceive of dark matter as being analogous in atomic constitution to ordinary matter? There are principally different opinions about dark matter. Why? In my opinion, there are two different issues with dark matter objects and dark matter particles. Usually, dark matter objects are accepted because the existence of them is experimentally proved. 240 years ago, John Mitchell predicted binary systems in which a dark star and a normal star orbit around their center of mass, and they were identified by astronomers in 1971, 180 years later. Binary galaxy systems, including dark galaxies, were discovered by Giovanelli and Haynes in 1989 and by Minchin et al. In 2000. In 1933, Zwicky investigated the velocity dispersion of Coma supercluster and found a surprisingly high mass-to-light ratio, about 500. He concluded, if this would be confirmed, we would get the surprising result that dark matter is present in much greater amount than luminous matter. Masses of superclasses can be estimated by gravitational lensing also. The main issue is with dark matter particles, for which there are no direct observations. They have no electrical charge and cannot be investigated by mass spectrometry. I would like to stress that there are many particles without electrical charge: neutron, neutrinos, gluon, Higgs boson, etc. Nevertheless, we accept them without direct observations. Why do we have so much prejudice against dark matter particles? Indirect effects in cosmic rays and gamma ray background from the annihilation of cold dark matter in the form of heavy, stable, neutral leptons in galaxies were considered in pioneer article by Nobel Prize laureates in physics Lee and Weinberg in 1977. Bohm follows this idea and introduces a multi-component system of self-annihilating dark matter particles that behave like Majorana fermions, which are their own antiparticles. In 1952, Nobel laureate in physics Nambu proposed an empirical mass spectrum of elementary particles with a mass unit m0/2 close to 1/4 of the mass of pion. He noticed that meson masses are even multiplies of a mass unit. Baryon and also unstable lepton masses are odd multiplies, and mass difference among similar particles are quantized by M0 70 megaelectron volts. In whom I introduced a basic energy unit E0 that equals to 70 megaelectron volt, where H is the Planck constant, C is the electrodynamic constant, and A is a basic size unit. I emphasize that the rest energy of electron equals to alpha multiplied E0, and the Rydberg unit of energy equals to half alpha cube E0. R is the Rydberg constant. It is the main goal of WOM to develop a model based on two-dimensionless parameters only. Dimensionless Rydberg constant alpha, that named now fine structure constant. Dimensionless time-varying quantity Q, that is a measure of the size R and H are A tau for the world. Q equals R over A tau over T0, where T0 is a basic time unit, which in a present epoch, I mean Q, equals to the value 0.76 multiplied 10 to the power 4, and is in fact the Dirac large number. Considering the main goal of WOM, the rest energies of dark matter particles should be proportional to constant alpha only. WOM postulates that rest energies of dark matter fermions and bosons are proportional to the basic energy unit E0 multiplied by different exponents of alpha and can be expressed with the following formula in the created model of dark matter particles. This is the formulas. This is the formulas. In our view, this created table of dark matter particles covering 18 orders of magnitude of rest energies is the analogous in atomic constitution to ordinary matter, as Ian Cowan said in the previous presentation. The reason for this multi-component dark matter system is to explain the diversity of very high energy gamma ray sources in the world. In presentation 2, we discuss experimental conformations of the proposed dark matter particles in very high energy gamma spectrum. The diversity of dark matter cores of macro objects of the world: extrasolar systems, DMF1 and DMF2, galaxies, DMF3, superclusters, DMF4, which are fermion compact objects, and dark matter reactors in WOM. In presentation 3, we discuss macrostructures of the world with these dark matter cores. DMF4 are responsible for unidentified infrared emission bands. Main infrared features occur around peaks at 3.3, 6.2, 7.7, 8.6, 11.2, and 12.7 micrometers, which are fingerprints of all galaxies. Diracs, which are magnetic dipoles of Dirac monopoles, are introduced to explain the Dirac's quantization condition. All electric charge in the universe must be quantized. Alloys, which are dipoles of prions with electrical charge E over 3, are the building blocks for quarks. Xions are responsible for lethargy mechanism of gravitation at broadband 21 centimeter emission. Introduction. The discovery of supermassive compact objects at the center of our galaxy, Nobel Prize in Physics 220, made by Genzel and Guess, is a confirmation of one of the most important predictions of WOM in 2013. Macro objects of the world have course made up of the discussed dark matter particles. Other particles, including dark matter and baryonic matter, form shells surrounding the cores. I would like to stress that Genzel and Guess named the object supermassive compact object, but not supermassive black hole, as it was only accepted explanation. There are no black holes in WOM. Recently, a population of large, very low surface brightness spheroidal galaxies was identified in the Coma cluster. One document in 2019 presents the stellar kinematics of Dragonfly 44, one of the largest Coma ultra-diffuse galaxies, whose mass about equals that of the Milky Way. However, the galaxy emits only 1% of the light emitted by Milky Way. Astronomers reported that this galaxy might be made almost entirely of dark matter. The existence of nearly dark objects with this mass is unexpected, as galaxy formation is thought to be maximally efficient in this regime. Lian and Slatier in 2019, in the article Revival of the Dark Matter Hypothesis for the Galactic Center Gamma Ray Access, examined the impact of unmodeled source populations on identifying the true origin of the galactic center gigaelectron volt access. The authors discover striking behavior consistent with mismodeling effect of the real Fermi data, finding that large artificial injected dark matter signals are completely misattributed to point sources. Consequently, they conclude that dark matter may provide a dominant contribution to the galactic center gigaelectron volt access after all. On May 12, 2022, astronomers using the Event Horizon Telescope released the first image of the accretion disk around Sagittarius, produced using a worldwide network of radio observatories made on April 2017. These observations were analyzed by the international research team that now numbers over 300 people, which claimed that Sagittarius is a supermassive black hole. Below, we analyze these results in frames of room. Based on the totality of all accumulated results for the center of Milky Way, I conclude that Sagittarius is the dark matter core of our galaxy. WOM solves a number of physical problems in contemporary cosmology and astrophysics through dark matter particles and their interactions, angular momentum problem in birth and subsequent evolution of galaxies and extrasolar systems. How do they obtain it? We discussed this problem in the previous presentation 3. And Fermi bubbles, which are two large structures in gamma rays above and below galactic center, What is the mechanism of their radiation? We will discuss it below. World-Universe Model, macrostructures. Laniakea supercluster is a galaxy supercluster that is home to Milky Way and about 100,000 other nearby galaxies, see figure 1 and 2. It is known as one of the largest superclusters with estimated by Bliss binding mass 10 to the power 17 solar mass. Distance to the center of Laniakea supercluster is about 250 million light years. We emphasize that about 100,000 nearby galaxies are moving around center of Laniakea supercluster. They belong to Laniakea supercluster. All these galaxies did not start their movement from initial singularity. Neighboring superclusters have the same structure. It means that the world is in fact a patchwork quilt of main superclusters. Please, one more time, take a look at this real picture of our world. Macro-object jet model, in whom macrostructures of the world, superclusters, galaxies, extrasolar systems, have nuclei made up of dark matter fermions, which are surrounded by shells composed of dark matter and baryonic matter. The shells envelop one another like a Russian doll. The lighter a particle, the greater the radius and the mass of its shell. Innermost shells are the smallest and are made up of heaviest particles. Outer shells are larger and consist of lighter particles. A proposed weak interaction of dark matter particles provides integrity of all shells. We discussed this model in presentation 2. Table 2 describes parameters of macro objects cores, which are 3D fluid balls with a very high viscosity and function as a solid-state object, calculated based on the developed theory of fermion compact objects. The calculated parameters of the shells show that nuclei made up of DMF1 and DMF2 compose cores of dark stars in galaxies and normal stars in extrasolar systems. Shells of DMF3 and electron-positron plasma around nuclei made up of DMF1 or DMF2 make up cores of galaxies. Nuclei made of DMF1 and DMF2 surrounded by shells of DMF3 and DMF4 compose cores of superclusters. Formation of macrostructure. In frames of womb, Laniakea supercluster emerged 13.77 billion years ago due to a random explosive volcanic rotational fission of the supercluster of a spinning surface speed at equator exceeding escape velocity, dark matter core, and self-annihilation of dark matter particles. Dark matter core of Laniakea supercluster was created during dark epoch, spanning from the beginning of the world, 14.22 billion years ago, for 0.45 billion years, when only dark matter macro objects existed. Dark matter core of Milky Way was born 13.77 billion years ago as the result of rotational fission of Virga's supercluster dark matter core. Dark matter cores of extrasolar systems, planets, and moons were born as a result of the repeating rotational fissions of Milky Way dark matter core in different times, 4.57 billion years ago for the solar system. Macrostructures of the world form from the top, superclusters, down to galaxies, extrasolar systems, planets, and moons. In our view, random explosive volcanic rotational fission of dark matter core of prime objects looks like a firework of dark matter cores of satellite objects at the same time, so that the direction of the sum of satellites' angular momentum coincides with the angular momentum of the prime object. Dark matter cores of prime objects detonate at critical points of their stability, which principally depend on the accumulated rotational angular momentum. We discussed it in presentation 3. Milky Way. Milky Way is a bare spiral galaxy, which is a part of the local group of galaxies that form part of the Virgo supercluster, which is itself a component of Laniakea supercluster. The age of Milky Way and the oldest star, named Methuselah, is similar to the age of the world. The galactic center has an intense radio source known as Sagittarius. In 2008, Guess et al. Found the enclosed mass of it 4.1 million solar mass. I emphasize that now with GWST, we are looking for the earliest and most distant galaxies, and at the same time, we live in one of the earliest galaxies, Milky Way. According to standard cosmology, massive mature disk galaxies with mass up to 10 to the power 11 solar mass cannot form for the amount of time 100, 400 million years, because it takes billion years to form them. So they should not be there at all. The experimental observations of galaxies in the fold show that most of them are disk galaxies. Milky Way is the second largest spiral galaxy in the local group after Andromeda Galaxy, with its estimated visible stellar disk diameter 185 kilolight years, thickness of thin stellar disk about 2 kilolight years, and mass 1.6, 3.2, 10 to the power 42 kilograms. The disk bubble contains interstellar medium and 100, 400 billion extrasolar systems. With Nikola Tesla's principle at heart, there is no energy in matter other than that received from the environment. We calculate mass of Milky Way according to this simple equation. From this equation, we calculate diameter of Milky Way 170, 240 kilolight years. The calculated value of the visible stellar disk diameter is in a good agreement with its estimated value obtained by astronomers. Considering the stellar disk diameter 185 kilolight years, we can calculate mass of Milky Way 1.92 10 to the power 42 kilograms. Average concentration of dark matter particles DMF3 in interstellar medium about 304 10 to the power 11 per cubic meter, which is significantly larger than the critical concentration that defines weak interaction, 5.3 10 to the power 10 per cubic meter. It means that weak interaction between dark matter particles DMF3 provides integrity of Milky Way disk bubble. Andromeda Galaxy is a bare spiral galaxy about 2.5 million light years from the Earth, and the nearest large galaxy to Milky Way with about trillion stars. It has an estimated visible stellar disk diameter about 220 kilolight years and mass 3 10 to the power 42 kilograms. Parameters of Andromeda Galaxy are close enough to the parameters of Milky Way. It seems reasonable that the calculations of the galaxy parameters made above for Milky Way are valid for Andromeda Galaxy too. Considering the fact that the calculated concentration of DMF3 is significantly larger than the critical concentration, we can suppose that our conclusions for Milky Way are fair for all galaxies involved. In whom galaxies emerged due to the explosive volcanic rotational fission of overspinning dark matter supercluster cores composed of dark matter particles DMF1, DMF2, DMF3, and DMF4. As a result of this mechanism, galaxy bubbles created which have looked like chicken eggs at that time. Yolk, spinning liquid dark matter core of galaxy with high viscosity composed of dark matter particles DMF1, DMF2, and DMF3. Yolk contains one-third of the total galaxy matter. Albumin, liquid interstellar medium with low viscosity made of DMF3 with dissolved other dark matter particles. Albumin adds up to two-thirds of the total galaxy matter. Membrane, boundary between interstellar medium and intergalactic medium with surface energy density sigma 0. Extrasolar system emerged due to the explosive volcanic rotational fission of a spinning dark matter galaxy core and anti-interstellar medium. As a result, galaxy bubble expands in the plane of the spinning galaxy's dark matter core and becomes a disk bubble. Center of Milky Way. Sagittarius is a supermassive black object at the galactic center of Milky Way, which was discovered in 1954 by Krauss, Coe, and Matt with radio telescope at 250 megahertz. It is a bright and very compact astronomical radio source. In 1982, Brown understood that the strongest radio emission from the center of Milky Way appeared to be due to a compact, non-thermal radio object. The Sagittarius cluster is the cluster of stars in close orbit around Sagittarius. One of the most studied stars is S2. Take a look at the figure 3. Star S14 is the record holder of closest approach to Sagittarius at about 1.88 10 to the power 12 meters, almost as close as Saturn gets to the Sun. Its orbital period is 12 years, but an extreme eccentricity of 0.985 gives it the close approach and high velocity of about 8% of the speed of light. In 2005, Eisenhower et al. Reported the results with 75 milliaxis resolution of near-infrared imaging spectroscopy within the central 30 light days of the galactic center. Look at one more time at this figure. These are their results. On January 5, 2015, NASA reported observing from Sagittarius a record breaker X-ray flare 400 times brighter than usual. According to astronomers, the unusual event may have been caused by the breaking apart of an asteroid falling into supermassive black hole. Can you believe it? In 2018, von Fellenberg et al. Reported the first detection of the galactic center in the far infrared. Their measurements were obtained at 100 and 160 micrometers. In 2019, the observations of several stars orbiting Sagittarius have been used to determine the mass and upper limits on the radius of the object. Based on mass and increasingly precise radius limits, astronomers have found that the enclosed mass of Sagittarius is 4.154 million solar mass, compared with 4.1 million solar mass obtained by Getz in 2008. A calculated Schwarzschild radius of its mass, 1.227 10 to the power 10 meters, is about 2 orders of magnitude smaller than the minimum distance of star S14 from Sagittarius, 1.88 10 to the power 12 meters. On 2021, NASA published new images of the galaxy center based on surveys from Chandra X-ray Observatory. Astronomers present a catalog of the detected X-ray sources in the range 0.37 kiloelectron volts. NASA has released a stunning new picture of our galaxy's violent, super-energized downtown. The image, a composite of 370 observations made over the past 2 decades, depicts billions of stars in the center of Milky Way. The author of these investigations, Wang, said, "What we see in the picture is a violent or energetic ecosystem in our galaxy's downtown." Warm explanation. The calculated value of the radius of the electron-positron shell, 2.9 10 to the power 10 meters, is in excellent agreement with the experimentally measured value of the radius source, 3 10 to the power 10 meters, by Liu et al. The calculated value of the mass of electron-positron shell, 6.6 10 to the power 36 kilogram, is in a good agreement with the experimentally measured value of the supermassive compact object, 8.5 10 to the power 36 kilogram, by Guest et al. In 2008. The additional mass of DMF3 shell of 1.9 10 to the power 36 kilogram is much smaller than the maximum mass of it, 1.2 10 to the power 41 kilogram. X-ray flare 400 times brighter than usual, observed by Chu et al. In 2015, can be explained by the detonation of DMF3 particles and their self-annihilation. The excess of gamma-ray emission with energy about 10 gigaelectron volt reported by Hooper in 2011 from the galactic center can be explained by DMF2 particle self-annihilation. The age of the Methuselah, found by Bond in 2013, can be explained by generation of this star by overspinning dark matter core of Milky Way 13.77 billion years ago. In frames of the rotational fission model, it is easy to explain hyper-runaway stars unbound from Milky Way with speeds of up to 700 kilometers per second. Marchetti et al. In 2018 observed it. They were launched by overspinning dark matter core of Large Magellanic Cloud with a speed higher than the escape velocity. Koposov et al. In 2019 present the discovery of the fastest main sequence hypervelocity star S5 with mass of about 2.3 solar mass that is located at a distance of about 9 kiloparsec from the Sun. When integrated backwards in time, the orbit of the star points unambiguously to the galactic center, implying that S5 was kicked away from Sagittarius with a velocity of 1800 kilometers per second and traveled for 4.8 million years to its current location. This discovery can be explained by gravitational burst of the overspinning core of Milky Way 4.8 million years ago, which gave birth to S5 with a speed higher than the escape velocity of the Milky Way core. Clark et al. In 2018 observed C-Tau, a young 2 million years old star, which is located about 500 light years away. They discovered that extrasolar system contains 4 gas giant planets that are only 2 million years old, an amount of time that is too short for formation of gas giants according to the prevailing theories. This discovery can be explained by gravitational burst of the Milky Way core 2 million years ago, which gave birth to C-Tau system with all the planets generated at the same time. Observations by Event Horizon Telescope collaboration. In May 2022, collaboration presented Event Horizon Telescope 1.3 millimeters measurements of the radio source located at the position of the supermassive black object Sagittarius collected during the 2017 April campaign. A deciphered image of Sagittarius is depicted in Figure 5. Take a look at these pictures. This is a Figure 4, and this is deciphered the image of Sagittarius A star. The observations were conducted with 8 facilities at 6 locations across the globe. Novel calibration methods are employed to account for Sagittarius flux variability. A few teams of researchers have attempted to image Sagittarius in the radio spectrum using very long baseline interferometry. The current highest resolution, about 30 microarc seconds measurement, made at a wavelength of 1.3 millimeters, indicated an overall angular size for the source of 50 microarc seconds. Take a look at these pictures. At a distance of 26.6 kilolight years, this yields a diameter of 6.3 10 to the power 10 meters. Multi-wavelength monitoring of Sagittarius was performed at 22, 43, 86 gigahertz and at near-infrared and X-ray wavelengths. Several X-ray flares from Sagittarius are detected by Chandra, one at lowest significance jointly with Swift on April 7, and the other at highest significance jointly with New Star on April 11. The collaboration compares Sagittarius broadband flux during this campaign to its historical spectral energy distribution and found that both the quiescent emission and flare emission are consistent with its long-term behavior. Astronomers of the collaboration have made a first comparison of the 2017 Sagittarius data to a state-of-the-art library of ideal time-dependent, general relativistic magnetohydrodynamics simulations models. The models assume that the mass and distance to Sagittarius are known and that the central object is a rotating, uncharged, supermassive black hole. It's a very good beginning. None of the fiducial models survived the full gauntlet of 11 constraints. The astronomers set aside both variability constraints and got 2 fiducial models that passed the remaining 9 constraints in all simulation pipelines. These models in the best bet region are strongly magnetized and have positive spin and low inclination. Based on the obtained results, the Event Horizon Telescope collaboration claimed that Sagittarius is a supermassive black hole. Below, we analyzed the obtained experimental results in frames of room. Analysis of Event Horizon Telescope results. In our opinion, the results obtained by collaboration are model-dependent and not sufficient to support this claim. Astronomers should answer some principal questions. The age of Milky Way is similar to the age of the world. The oldest star in Milky Way, named Methuselah, is nearly as old as the world itself. If Sagittarius is a supermassive black hole, then how it could grow so quickly? What is the origin of the alleged supermassive black hole positive spin? Their models is the best bet ray in the best bet region have low inclinations, 30 degrees and 10 degrees, that contradicts the disk shape of Milky Way and bipolar astrophysical jets, which are astronomical phenomena where outflows of matter are emitted at the extended beams along the axis of rotation. The Milky Way Galaxy, including Sagittarius, is gravitationally bounded with Virgo supercluster and has a huge orbital angular momentum calculated based on the distance of 65 million light years from Virgo supercluster and orbital speed of about 400 kilometers per second. How did Milky Way Galaxy obtain this very large orbital angular momentum? What is the mechanism of gamma rays emission from the galactic center? In frames of WOM macro-object shell model, which we discussed in presentation 3, the results obtained by the Event Horizon Telescope collaboration can be explained in the following way. The image is dominated by the bright, thick ring with the diameter 6.3 10 to the power 10 meters. The ring has a comparatively dim interior that is made up of dark matter fermions GMF1 and GMF2, which are responsible for the excess of gamma ray emission from the Sagittarius due to their self-annihilation. Dark matter particles are continuously absorbed by the interior of Sagittarius. Ordinary matter is a byproduct of dark matter particles' self-annihilation. It is re-emitted by the interior continuously into the shell around it. Very powerful gamma quants with energy of at least 1 megaelectron-volts in the vicinity of atomic nuclei of the shell produce electron-positron pairs with high concentration. The bright, thick area with the diameter 6.3 10 to the power 10 meter consists of ordinary matter and electron-positron plasma with a radius of 2.9 10 to the power 10 meters that is a compact, non-thermal radio object responsible for the strongest radio emission from the center of Milky Way. The area from the radius of 3.17 10 to the power 10 meters to 1.88 10 to the power 12 meters is filled out with dark matter fermions GMF3, which are responsible for X-rays from the center of Milky Way due to their self-annihilation. The 400 times brighter than usual X-ray flare reported by NASA is the result of the detonation process inside of this shell, which does not destroy it. Instead, hyperflare occurred in active region of the shell analogous to solar flares. The enclosed mass of supermassive compact object, 4.154 million solar mass, is the mass of the Milky Way dark matter core made up of GMF1, GMF2 with electron-positron shell and GMF3 shell. Sagittarius has gotten the rotational and air orbital angular momenta as the result of the rotational fission of the dark matter core of the Virgo supercluster. The totality of all obtained experimental results testify in favor of the existence of the supermassive compact object made up of dark matter particles at the Milky Way center. Dark matter Fermi bubbles. In 2010, the discovery of two Fermi bubbles emitting gamma ray and X-rays was announced. Fermi bubbles extend for about 25 kilolight years above and below the center of the galaxy. The outlines of the bubbles are quite sharp, and the bubbles themselves glow in nearly uniform gamma rays over their colossal surfaces. Gamma ray spectrum remains unconstrained up to around 1 tera-electron volts. Years after discovery of Fermi bubbles, their origin and the nature of the gamma ray emission remain unresolved. Su and Finkenbeiner in 2012 identified a gamma ray cocoon feature in the southern Fermi bubble, a jet-like feature along the cocoon's axis of symmetry, and another directly opposite the galactic center in the north. Both the cocoon and jet-like feature have a hard spectrum from 1 to 100 giga-electron volts. If confirmed, these jets are the first resolved gamma-ray jets ever seen. Ponti et al. In 2019 report prominent X-ray structures on intermediate scales, hundreds of parsecs, above and below the plane, which appear to connect the galactic center region to Fermi bubbles. These structures, which they term the galactic center chimneys, constitute exhaust channels through which energy and mass is injected by a quasi-continuous train of episodic events at the galactic center and transported from the central few parsecs to the base of the Fermi bubbles. Hooper and Slatier in 2013 discussed two emission mechanisms in Fermi bubbles: inverse Compton scattering and annihilating dark matter. In their opinion, the second emission mechanism must be responsible for the bulk of the low energy, low latitude emission. The spectrum and angular distribution of the signal is consistent with that predicted from 10 giga-electron volt dark matter particles annihilating to leptons. This component is similar to the excess giga-electron volt emission previously reported by Hooper and Goodenough in 2011 from the galactic center. It is worth noting that a similar excess of gamma rays was observed in the central region of the Andromeda Galaxy too. McDaniel, Geltema, and Profuma in 2018 calculated the expected emission across the electromagnetic spectrum in comparison with available observational data from Andromeda Galaxy and found that the best fitting models are with the dark matter mass about 11 giga-electron volts. According to Young, Ruskowski, and Swebel, for understanding the physical origin of Fermi bubbles, three major questions need to be answered. First, what is the emission mechanism? The bubbles can either be hadronic, where the gamma rays are produced by inelastic collisions between cosmic ray protons and the thermal nuclei via decay of neutral pions, or leptonic, where the gamma rays are generated by inverse Compton scattering of the interstellar radiation filled by cosmic ray electrons. Second, what activity at the galactic center triggered the event? Are the bubbles associated with nuclear star formation or active galactic nuclear activity? Third, where are the cosmic rays accelerated? They could either be accelerated at the galactic center and transported to the surface of the bubble, or accelerated in situ by shocks or turbulence. Note, however, that not all combinations of the above three considerations would make a successful model because of constraints given by the hard spectrum of the observed bubbles. Warm explanation of Fermi bubbles. Warm explains Fermi bubbles the following way. Core of Milky Way Galaxy is made up of dark matter particles DMF1, DMF2, and DMF3. The second component, DMF2, explains the excess giga-electron volt emission reported by Hooper from the galactic center. Core rotates with surface speed at equator close to the escape velocity between gravitational bursts and over the escape velocity at the moments of gravitational bursts. Bipolar astrophysical jets of dark matter particles are ejected from the rotating dark matter core of Milky Way into the galactic's halo along the rotation axis of the galaxy. Due to self-annihilation of DMF1 and DMF2, these beams are gamma-ray jets, which were discussed by Su and Finkenbeiner. The prominent X-ray structures on intermediate scales, hundreds of parsecs, above and below the plane, named pointy galactic center chimneys, are the result of the self-annihilation of DMF3. Fermi bubbles are bubbles whose boundary with the intergalactic medium has the basic surface energy density sigma 0. These bubbles are filled with dark matter particles DMF1, DMF2, and DMF3. Fermi bubbles are macro objects with a mass and diameter which are proportional. Mass to Q in power 1.5 and diameter in the power Q in 3/4, respectively. In whom the diameter of Fermi bubbles equals to 28.6 kilolight years, where L DMF3 is the Compton length of particles DMF3. The calculated diameter is in a good agreement with the measured size of the Fermi bubbles, 25 kilolight years by Angulera and Pulliam, and 32.6 kilolight years by Ponti. Weak interaction between dark DMF3 particles provides integrity of Fermi bubbles. With Nikola Tesla's principle at heart, there is no energy in matter other than the received from the environment. We calculate the mass of Fermi bubbles by the same equation that equals about 3.6 10 to the power 41 kilograms. Recall that the mass of Milky Way Galaxy is about 1.6, 3.2, 10 to the power 42 kilograms. It means that the Fermi bubbles have mass about 10 times less. Fermi bubbles radiate X-rays due to the self-annihilation of DMF3. Gamma rays up to 1 tera-electron volt are the result of the self-annihilation of DMF1 and DMF2 in dark matter objects whose density is sufficient for the self-annihilation of dark matter particles to occur. On the other hand, dark matter macro objects are much smaller than stars of the world and have a high concentration in Fermi bubbles to provide nearly uniform gamma-ray glow over their colossal surfaces. A total flux of the gamma radiation from Fermi bubbles is the sum of the contributions of all individual dark matter macro objects, which irradiate gamma quants and with different energies and attract new DMF1 and DMF2 from Fermi bubbles. The core of Milky Way supplies Fermi bubbles with new dark matter particles through the galactic wind, explaining the brightness of Fermi bubbles remaining fairly constant during the time of observations. In our opinion, Fermi bubbles are built continuously throughout the lifetime of the Milky Way Galaxy. Fermi bubbles made up of DMF3 particles resemble a honeycomb filled with DMF1 and DMF2. Conclusion. The totality of all obtained experimental results testify in favor of the existence of supermassive compact objects made up of dark matter particles at the Milky Way center and validate the developed world-universe model. In our view, Fermi bubbles are dark matter particles clouds containing uniformly distributed dark matter objects in which dark matter particles self-annihilate and radiate gamma rays with energies covering nine orders of magnitude from kiloelectron volt to teraelectron volt. Dark matter Fermi bubbles constitute principal proof of WOMB. Acknowledgements. I'm always grateful to academician Alexander Prokhorov and Professor Manenkov, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of physics in a new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in the Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival for his useful comments and suggestions, which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify the model and improve its understanding. This is the end of my presentation. Thank you so much for your attention.
So, Nick, good day to you. You're up now. So, what did you want to add, or to what Danny?
Yes, Dennis gave a very accurate critique of mainstream academic physics idea of dark matter, which I also dismiss. But that's totally different than what Vladimir is talking about. And hence we have this terminology between. So a lot of people are dismissing Vladimir when he talks about dark matter based on ideas that are totally irrelevant to his thesis and why he has come up with dark matter particles. So hopefully this will help people to not prejudge and dismiss what Vladimir is saying when he uses the term dark matter.
Thank you for that, because I rather suspected much of that, but I haven't had it clearly stated. So maybe the plea is going forward now for the next number of sessions. We need to consider that what Vladimir is saying, even though some of the terms are maybe similar to what mainstream has used, many of us might think inappropriately. We should suspend our judgment and just look at what Vladimir is saying and the empirical evidence that he has to substantiate that. So is that okay, Nick?
Yes.
Thank you for that. Thank you indeed.
Thank you so much for your comment.